Okay, so on number 4, says Mark is running a race. The distance, y, from the starting line after any number of seconds, x, is represented in the graph below. Just looking at the graph, so put your pencils down. I don't want you to think about answering any of the questions. I just want you to look at the graph and figure out what you understand by just looking at the graph. So what is something that you can come up with, Aaron? Give me one thing.
It's proportional.
It is proportional, so how do you know that? Goes through the origin, good. What is something else that we can come up with just about him running a race? Brendan?
The distance is getting higher instead of going backward.
Yeah, the distance is getting, well, how do you know the distance is getting higher? Good, the slope is increasing, it's going up, and he pointed his arm up like this, because the graph is going up to the right. Yes, what else do we know about this race? Just by looking at the graph. Eli, what'd you come up with?
It starts at 0.
It starts at 0. Yeah, good, so here's the starting line of the race. Here's Mark, correct? This is the start. He's right there on 0. Sweet, good. So just by looking at the graph, you guys can figure out a lot of information. Now part A says, what is the y-intercept? Well, Eli said he started at 0, correct? So this y-intercept, remember, the graph is intersecting the y-axis. The y-intercept starts at 0. Make sure you write starts at 0, because I'm trying to get you to learn that the y-intercept is just another way to ask you what is the starting point. Then on part B it says, is the relationship proportional? And Aaron already told us that, is it?
Yeah.
Because the graph starts where? And what's the y-intercept? 0. So yes. Then it says part C, what is the slope, that rate of change? So if I ask you what is the rate of change, you're gonna tell me slope. If I ask you what is the slope, that's the same thing as telling me the rate of change. So in order to find the slope, we're gonna look at my graph. We need 2 points. This is a good point. This point is on the graph. Is that a good point to use? No, because you kind of have to guess. This point is on the graph. Is that a good point to use? Yeah, because we know that it is exactly located at 2 seconds, and, uh-oh, there's not a number there, is there? 10? Well, how'd you come up with 10? There's no number there. It's counting by 10, so if I go 10, 20, 30, 40, 50, 60, 70, oh, absolutely correct. Count by tens. So this is point 2, 10. So before we even start finding the slope, we're gonna write our ordered pairs down. So I have point 2, comma, 10. And then we have point 0, comma, 0. Make sure you label this as your X, that is your Y. Some of you, when I went back to look at Julia's paper, I did not see this on your paper. Then to find the slope, find slope. So you should have these ordered pairs listed here and here. We're gonna do y sub 1 minus y sub 2 over x sub 1 minus x sub 2, correct? Looking at my y column, what is my first y, everybody?
10.
10, so I'm gonna do 10 minus y sub 2, so that means go back to your y column, and what is my second y?
0.
0. Now, what label is listed on the y-axis? Is it seconds or feet? Feet. Then we're gonna do y sub 1, so I'm gonna go, x sub 1, so I'm gonna go to the x column and write down my first number, which is
2.
2, and we're going to subtract x sub 2, so we're gonna go back to the x column and write down the second number, which is
0.
0. These are my x's, so here's my x-axis. What label is on the x-axis?
Time.
Time, which is measured in seconds. Ten minus 0 feet is
10.
10 feet. 2 minus 0 seconds is
2 seconds.
huh?
If I found that you said this was for number, I thought I put 840 and then 630.
So you use different ordered pairs, and so, yeah, it works every single time, as long as those 2 good points are on the graph, you're good. Take your leading numbers, 10 divided by 2 is, and now, we gotta figure out, is it seconds per feet or feet per second, so, just like in reading, we're gonna do feet per second. So in 1 second, how far can Mark run?
5 feet.
5 feet. Yeah, that's 5 feet per second. So, the slope is called the rate of change because doesn't his distance change, doesn't his distance change by 5 feet every second? Then on part D, it says write an equation to represent Mark's distance y from the starting line after any number of seconds. So I'm gonna do part D here, so I don't have to bend over. His distance, y is it feet on the y-axis? So y stands for feet equals, we're putting our slope, or our rate of change, and his distance is changing by 5 feet every second. What axis is the seconds on, the x or the y?
Feet.
So x, so I'm gonna put, this is my number of seconds. And then we need to put that starting point there, plus 0. Now, if the starting point is 0, do we actually have to write plus 0?
No.
Because does adding 0 to anything ever change it?
No.
So you actually do not have to put, if the starting point's 0, you don't have to actually write it. You can save yourself a little bit of writing. Go ahead, RJ.